The infrastructure actually is one of the pillars to succeed in delivering economically, let's say, calculated, let's say, set the digital business. We continue from where we stopped. Actually, we were defining the context of the theoretical definitions, and more specifically, we talked about the Moore's law. Here we can see actually one of the effect Moore's law is drawing. Upon time, the advancement in creating, let's say, microprocessors, the CPUs, the central processing units, the let's say, component processing the digital, let's say, data, digital activities, or whatever, the processor, CPUs. Upon time, actually, we are able to see the advancement being commercialized to public use. What we see actually on the bottom of this graph here, the most bottom layer here is the biggest in size, which is having actually a number, which is actually an enormous number to us as humans to calculate. 200,000 let's actually microchips or something like that. That leads to calculate actually an enormous number of calculations by just one click. It's a matter per second. The calculation is per second usually. While at the early age, here, 1970s, as per this graph only, as per this reference only, we would have actually the same scenario, a CPU to calculate, to make a chip, and actually a process is being terminated, yet with a very low capabilities when we compare to nowadays. We may talk about a very weak number of, let's say, microchips, let's say core components to calculate, let's say, transistors to calculate, to finalize the amount of calculations in the early processors. When you compare that to today's, actually, we may talk about billions and billions of chips inside the microchip here, the transistors inside of this layer here. There are billion transistors. I'm not going to say, as per this reference here, as per the date of the writing of this book, the generation of the piece of processor, they were able to receive 5 billion transistors in one chip only, the processor, which is an enormous number, which is actually to make the computers so fast, trusted to, let's say, to deliver qualitative services, digital services. This number of 5 billion transistors will not be able to be received here in such let's say, processors at the early age. This is what the Moore's law draws. We, let's say, go on time, technology gets advanced actually. Billions of transistors being packed in the same processor to deliver, let's say, very, let's say, fast computers with a lower, let's say, with a lower price. Here, it is actually having a small number of transistors. Does not mean it's cheaper than this one. No. It is being packed thousands and then after billions of, let's say, transistors, and still the price is going down, not increased, because of the technology. Because of the technology. The technology helped in making transistors actually being, let's say, packed in one microchip to make activities much more faster with a low budget, with a low price. Moore's law, remember, Moore's law. This is actually what the Moore's law defines here in this context here. Are you with me, everybody, please?
Yes.
If you are just actually opening any recording or something like that, so just close it, please. I'm not able to see who is opening that, but even though We continue. Yeah, actually, what we defined here right now, it is being seen here in a graph. Small number of chips, higher price. Bigger number of chips, let's say, and transistors, lower price. Good. The technology actually being helped actually when we say that we're going to pack billions of transistors in just one microchip. How it happens actually? We say billions of transistors means billions of, let's say, servlets that can help in making calculations because of so many actually and numerous technologies being packed at the same time. Amongst of that, the nanotechnology. Nanotechnology can help in packing tiny transistors, tiny in size, to do the same actually activity as per the regular transistors, in size also. So the size is being reduced due to the technology again, to help in packing billions of transistors in the same microchip at the same time. Nanotechnology can help in that. Nanotechnology can help in that. In this graph here, we can see 3 nanotubes. In this graph here, we can see 3 nanotubes inside of each other. And they are completely isolated. None is touching the other. They actually, yeah, superposed, yeah, absolutely. Yeah, even though here we can see the effect of, let's say, the realization of the nanotechnology to help in generate nano, let's say, tiny components, which here in our context we need the transistors. We discussed the transistors with the same capability as per the regular transistors in question. Yeah, the same thing here. Actually, the nanotechnology would help in decreasing the price, yeah, increasing the capability, the efficiency, yet still decrease the price. Technology would help in making the services much more better, faster, efficient, and with the lowest price. Proportionally, when we say actually here lowest price, it's a matter of proportionality. It means does not mean we will have actually much more higher quality with very less price. It depends on the scenario, and it is a matter of proportionality. When we compare the new technology with the older technology, we see that the price is much more less and lesser. The second law actually is another law. It's not a matter of numbering here. Metcalfe's actually a law. It helps in drawing a context of relationship and proportionality between the service and the end users at the end of the day, based on the demand in question. So Metcalfe's law, it would describe the remote access that would increase the use, and since the service is being delivered and being available to everybody remotely, anytime, everywhere and anytime, sorry. So the partnership with the end users, the consumers at the end of the day, would be done through computer networks and computerized networks. And this would actually increase the chance to have actually to build the intimacy and to gain new customers. And this is actually the positive effect of the, let's say, network or computer network, the internet, the web. All of them, they can give such a revenue value. Metcalfe's law. Why we discuss this point here, Metcalfe's law, actually, because when we want, for example, to increase the market, and we need, for example, 1,000 users to be increased in our network. 1,000 users, if you're just going to visit them one by one physically, we would actually have an economic problem. A budget has to be actually provided for that. Yet when we talk about the digital framework, the internet or the network in general, we would be actually talking about an economical let's say, approach. We will reach the same 1,000 users with a very less price, with a very less cost and budget due to the technology only. Here again, the technology interferes. Yeah, proportionality, no more, no less. It's a conclusion to what we were discussing. Whenever the technology gets advanced, efficiency and quality gets actually raised up, economical impact reduces, and the budgets are being less. So this is actually what we can conclude here on this view due to the infrastructure evolution. Again, here we're going to, let's say, surround and, let's say, create a bound to upon the infrastructure. It's not a matter of sequentially ordering those components here, but we have to recognize them this way here. They have to be available this way, because we may find other components, tiny components, new entrant components, new available components due to the advancement of and the evolution of the tech infrastructure. Yeah, for now, we're going to, let's say, surround those components in this way. The first actually is the complexity hardware infrastructure, to talk about the digital environment. Without hardware equipment, we'll not talk about any other thing. So the first is the hardware, the first component. Every and each single hardware has to have an OS to control, operating system. If you're having a mobile device, or, let's say, a laptop, or computer, or a server, or even a printer, or something like that, there have to be actually an operating system dedicated to that device to control it. It's a software. But this software is an operating system. It's a system software. On top of which, we may discuss, and we have to find the utility and the utility tools, the software applications, not systems. Here we talk about the applications, the software dedicated to different tasks. You're going to print something, you are going to generate a report, you are going to share something, you're going to open the internet and the web. All of those activities can be done only through software applications, browsers, let's say editing tools or something like that, whatever the task you are in front of. Then actually, if we talk about, for example, the social media software applications, one of the very pillars that we actually have to solve as an issue, which is the storage, where to store the media data, actually the media being shared and communicated between the parties. So the storage management, the scenario of the storage and their management also, both of them, they are context of one of the utilities that we may refer to. Those are actually, this is a mixture in between hard and soft. The storage, we need actually a storage device. The management is a matter of a software, the BMS, for example, to use to manage the data being stored, something like that. On top of that, we may talk about the remote access and the delivery of services remotely. We will use computerized networks, something like that, whatever, internet or any other. It's the computerized networks at the end of the day to help terminals being see each other and communicate and share resources. More specifically, when we talk about the computerized networks, we talk about the internet. And the internet is made up of two, let's say, views. The internet, the physical network, the physical computer network, IP-based network, internet protocol-based networks, and the web, www web, the World Wide Web platform, the physical and the logical network. Both of them, they actually delivering certain types of services and can be utilized as an infrastructure, delivering digital businesses. On top of that, on top of all of this, we may talk about the integrated services, or let's say systems dedicated to specific tasks. The consultant systems being integrated for specific tasks to dedicate their activity to a specific, let's say, services. still here to talk about the software applications dedicated to specific, like we talk about the firm actually, ERP is the best thing actually discussed here in this example. ERPs, we discussed at an early age, what is the ERP? ERP, Enterprise Resource Planning. It's something like the EduWave. It's a system software that manages an organization resources and, let's say, full digital services. ERP, something like that. Yeah, here actually, we may see them actually in correlation. They have to be actually available, all of them. Okay, to give the chance to everybody be here and stop the explanation at this level, and I give you the code. But I need questions from you actually. Any questions, please? Do you have any questions at this level?